So in this video, I'm actually going to go over the introduction to matrices, and I'm also going to be including the addition and the subtraction of matrices. The multiplication will be in another video, which I'll cover another time. I won't promise a date, but let's just go into matrices now. So what we are talking about matrices, I'm pretty sure you've seen those before. Let's say that we have an element, let's say P, right? If we have an element P, or actually we're naming our matrix P, the elements that are inside of this matrix P will be as follows. I'm just going to make them up, right? Let's say we have 5, 3, 2, and 1, for example, right? You've seen something like this before, and you're probably wondering, what on earth? If it's your first time doing matrices, then, well, welcome. If it's your second time, or if you're trying to revise over the matrices, then hello there. So what I want to do in this video is to try and compare it to what we have done in high school to see that there is a comparison. And what is the comparison to? Area, but area in terms of the rectangle. Okay, so what am I trying to say over here? So area of the rectangle, right? Okay, it's not exactly the area of a rectangle, but what I want to actually get through is I want to explain it like this, right? So let's say that we're looking for the area of a rectangle, right? Let's say we have a rectangle over here. Not the best looking rectangle, but it's fine. And we have a length that's equal to 3 units. And then they have a breadth which is equal to 2 units, right? Just for example, right? Then what we're going to be doing is we are going to divide it into its components such that we have like this. So length is our horizontal component here. So we're going to divide it such that there are 3 rows. And you see, rows are a key word over here, right? So that's how because I'm looking for the area, right? And in our breadth, we need to break it up into its components of vertical components, which is 2 units. So we're just going to half it so that we can get. So basically what I did over here, right? Sorry about that being fast over here. The 3 units represents that there's 3 rows, right? Like that, because it's all parallel to the length. And then here, by the breadth, it's 2 units, which is the columns of this rectangle over here. All right. And what do we see over here? We have 1, 2, 3, 4, 5, 6, right? And that actually represents the area. And why does that represent the area? Because if we say the area of a rectangle, that will be equal to 3 units multiplied by 2 units is equal to 6 units. And that is exactly what I'm trying to explain over here. If I were to correlate what exactly I said over here, let's look at this, right? Let's look at the matrix here. You can see that there are 1, 2, 3, 4 elements, and we call these elements, right? So element 1, so this would be element 1, element 2, element 3, and element 4, right? So we name these elements over here. Now, something we need to consider is also, apologies for naming these elements. I don't know. I'm pretty sure I didn't name them correctly, but let's just continue on with this video over here, right? So we can see there's 4 elements in this matrix P, and we need to split them up, right? So I'm going to do this. And what we looked at over here was, with the area of a rectangle, we can see that there are 6 blocks, but we can see that there are 3 rows and 2 columns, right? And our so our rows will represent the horizontal components, and the column will represent our vertical components, right? So let me just do it like this, actually. So therefore, if we were to look at it like this, our rows would be the horizontal ones. So let me extend this. This would be our first row. Remember, we need to name it. Okay, so whenever it's rows, we're going to name it from top to bottom. So that the top one will be row 1, and then the bottom will be row 2. Okay. And then if we were naming the columns, we need to name it as its vertical components, or the vertical set of elements, which is going to be column 1, and then this one would be column 2. And notice how it's actually a 2 by 2, because there are 2 columns. So 2 columns, and then we have over here 2 rows. So that would be a row by column in terms of, if we were to correlate it to area, right? So I'm going to do it over here. Let's look at area like this. So remember in maybe the shops, if you've been at like maybe like the plastic factories or any factory, they would label the area, or even any product that you can see in shops. Not any of them, some of them. You'll see an area like this, right? You'd say, let's say for example, it's going to be 200 by 100, and it'll say maybe centimeters, right, outside, because centimeters is distributed between the two over here. So they just take centimeters out as the common factor if we were to look at it mathematically. This actually represents the area. So in our case over here, if we were to correlate the area towards our matrices, we would look at it as row by column. In this exact order, we have to look at it at row by column. Otherwise, we are incorrect in our matrices calculations and so on and so forth. Okay, now let's do the following over here. If we were to name a matrice, let's say this matrice P, we would name it by the row by the column. And what is our row and column? So it'll be look like this. Our number of rows, which is 2 rows, so that goes there, by the number of columns, which is 2 over here. But you would normally actually write it like this, P 2, 2. So that would actually represent the P row column. I would write it like this, because that is how we look so cool. We are in the matrix, literally. Okay, now that was a silly one. But anyway, let's continue with the learning. So I've introduced you to matrices and basically our columns and rows. Okay, so let's go into a little bit more detail, but now let's add and subtract our matrices. How on earth are we going to add and subtract? Let's stay tuned for the following. So here are two matrices, A and B. And what we can see over here, right, we are asked to do the following. We need to say determine what is A, matrice A plus matrice B. What is that equal to? Now, because both of them are in matrice forms, we need to have a matrice form, same as that. So if we are adding and subtracting, we will get a final answer of as we can count 6 elements, right? So how are we going to do this? Let's consider the following, right? In matrix A, we have 1, 2, 3. So we have 3 columns, column 1, column 2, and column 3. And then over here in our rows, we have row 1 and row 2. And let's look at our other matrice. It's the exact same thing. So I'm not going to write it down again, but I'm going to write the rows here again, though, because our columns are aligned, basically. So that is a greater understanding over here of what we are going to be doing. And just because it's addition doesn't mean it's commutative. I know it can be commutative, but let's please consider the order. It's really going to help you, especially when you go into multiplication, because once you don't consider the order of when you are multiplying certain elements, you are going to have a completely incorrect answer, and especially with subtraction, that is not commutative. So let's focus on the order mainly. So what we are going to say over here, right, is the matrice, the addition of the two matrices is basically going to be the one element plus that same corresponding element of the other matrice, right? So we can see in column 1, row 1, we have 4, for A, we have 4, and for B, we have 1. So we are going to add those two together. So it's going to be 4 plus 1. That is our first element. Let's do the next one. In column 2, row 1, row 1, column 2, we have 0, and row 1, column 2, and B, we have 0. So that will just be 0 plus 0. Note how I'm not adding anything over here, because remember, we have a set of elements. We need to do it in the form of what we had in A and B. But now we are adding the elements. And now we have for row 1, column 3, we have 2 and we have 1. So I'm not going to now say that all the time. I'm just going to assume that you understand what we are doing. So that's 2 and 1. And then the same thing, we have 3 and 3. So we're going to add those two together. 3 plus 3. Then our next element is going to be the sum of these two, which is 2 and 2. So it's 2 plus 2. And then our next element will be 5 and 3. Okay. Now, we just need to simplify. We need to simplify so that we can show what is the sum of these two matrices. A plus B is just going to be equal to, and then we have the following. 4 plus 1 is just equal to 3. 0 plus 0 is 0. 2 plus 1 is equal to 3. 3 plus 3 is 6. 2 plus 2 is 4. And 5 plus 3 is 8. And there is our sum of our matrices. Something cool I just want to quickly add is the transposing of matrices, because I feel if we were to transpose, let's say, a random matrix Q, right? So a matrix Q, for example, and we have the following. Let's say we have a set of 4, 0, 2, 9, so maybe let's say 3, 1, and 5, right? And we want to transpose this. So how we're going to represent it is we're going to say T over here is going to be then equal to, if we're transposing it, then we're going to do the following, right? So then we're going to say that it's going to be, so okay, how about this? I think let me explain it like this, right? So when we are transposing, we're basically doing the inverse. So where we have column 1 and column 2 over here, and we have these rows over here, where we have row 1, row 2, and row 3, we have the following. We have row by column, right? So we're doing it row by column. We have 3 rows by 2 columns. But when we are transposing, we are essentially doing the inverse. So we are going to then swap them around. That's what our transposition is. If you were to be on Microsoft Excel and you came across the paste function, or sorry, the paste option, and it would say maybe transpose, it would basically inverse the data from, let's say, for example, it was horizontal data, and if you transpose it, it's going to become vertical data. So when ours was mainly vertical, you can see it's mainly vertical because of the width in terms of our horizontal is actually smaller than our length in terms of our columns, our column length. Okay, cool. And now what we're going to be doing over here is transposing it. So when we had column 1 being all of these values over here, that is just going to be our row 1. So let's look at it like this. Our new row by column is going to be the inverse, like I told you. So now it's going to be 2 by 3. Okay, cool. And now what I want to do over here is now I'm going to inverse it. So now it's actually going to be, let's do it like this. It's going to be, the first column is now going to be the first row of the new one, of the transposed matrix. So now it's going to be 4, 2, 1. And then our second column is now going to be our second row of our new transposed matrix. So it's going to be 0, 3, and 5. Now you can see the following. This is now going to be column 1, this is column 2, and column 3. And then this is going to be row 1 and row 2. And you can see how they flipped around. And that is how you transpose matrices. Now let's move on to subtraction. Okay, so lastly, we have the subtraction of matrices. So they say that we need to subtract matrix B by matrix A, right? So we have our two matrices, right? I know I could have said what is A minus B, but I want to make it a little bit, I want to introduce you to the order issue that we will come across, right? So whenever we are adding and subtracting, we will know that a number of columns and rows will stay the same for A minus B or even B minus A because it's subtraction and addition. We are only subtracting or adding the corresponding elements for each matrix. So here is column 1, here's column 2, here's column 3, and then over here, I want to also do that. This is going to be column 1, column 2, and column 3. Here it's going to be row 1, row 2, and row 3. Here is going to be row 1, row 2, and row 3. Okay, cool. So as you can see, now we have 3 rows and 3 columns this time. So this is a 3 by 3 matrix. And this is also a 3 by 3 matrix. And notice, because we have 3 by 3, we can actually determine from this that it gives us the amount of elements that there are. 3 times 3 is 9, and here 3 times 3 is 9. And we can see there are 9 elements in this matrix, in both the matrices. So that is why, and once again, we need to consider the order, rows by columns. I'm going to engrave it into your skull that the order really matters. Okay, I'm pretty sure maybe your lecturer even did the same thing. Okay, I don't know why I'm deleting that. Okay, let me just move this a little bit downwards then. Cool. Now we need to do this matrix over here. Right? So, what we need to do is consider the following. We need to minus B by A in that same order with respect to the order that it's given. So that means we need to first look at B, then we need to subtract it by the same the corresponding element of the different matrix, which is 3. So the first one is going to be 2 minus 3. And now we have over here, also note that there can also be negative numbers, but for this one, I'm just trying to keep it a little bit basic for this moment, so just bear with me for now. And then obviously for this one over here, sorry, we're looking at the matrix B, the column 2, row 1, we have 1, which is going to be our next matrix, minus our column 2, row 1 for 0, which is this one over here. And then I'm going to do the rest that you should know by now. We have 3 minus 2, which is represented here. And then we have the next element, which is going to be 1 minus 4, which is going to be like this, 1 minus 4. And then we're going to have 3 minus 1. And then we're going to have 4 minus 5. Then we're going to have 4 minus 0. Then 2 minus 0. And then 0 minus 4. Then we close up this matrix. It looks very amazing, eh? Now, let's simplify this matrix. Therefore, our matrix of B minus A, so the subtraction of our two matrices is going to be the following. We have 2 minus 3, which is equal to negative 1. We have 1 minus 0, which is equal to 1. We have 3 minus 2, which is equal to 1. That's a lot of 1s. 1 minus 4 is equal to negative 3. 3 minus 1 is 2. 4 minus 5 is negative 1. 4 minus 0 is just 4. 2 minus 0 is 2. And 0 minus 4 is negative 4. And that is how we get our subtraction of our matrices. And this is the introduction to matrices. And it's not that difficult at all. Matrices is actually one of the more basic ones, basic topics. And when we go further with matrices, you're going to see it's actually not that bad.